Hi everyone, this is a short video reviewing how we write linear equations. This is the second part to this sort of situation where we're given some information and we want to represent that information with a linear model. So we're going to look at a few ways, or a couple of ways that we can write a linear equation. Um, and you'll have to use or keep in mind what we looked at in part one, which is using the equation y minus y1 equals m times x minus x1, or y equals mx plus b. So let's just get started here. First things first, we can't do anything if we don't have any ordered pairs. So we need to write two ordered pairs based on the information above. And we need two ordered pairs because we can't figure out slope without two ordered pairs. So one possible ordered pair could be 1996 and 14.7. And then a second ordered pair could be 2006 and 14.14. And if I define what x is the year, right? Or a given year. Y is the birth rate, right? So sometimes it's a good thing, especially with the word problem, to define what your variables are. And in this case, x is year, y is birth rate. X is year, y is birth rate. Okay? Now, these are kind of big numbers here, 1996 and 2006, right? So we can also change our information as long as we're very clear about what we've done. So for example, we could write this as 0, 14.7. And basically what I'm saying is that x is years since 1996. So in 1996, it would be year 0, and that makes 2006 year 10, right? 10 years after 1996. 14.14. So this would be our x, and this would be our y. This would be our x, and this would be our y. Okay, so it does, if you're going to change the x values here, we got to make sure that we're defining it so that the reader understands just exactly what we've done. Okay, so hopefully you're with me here so far. So x is still the birth rate, but now in this situation, x is years since 1996. Okay, so assuming that this relationship is linear from 1996 to 2006, let's see if we can find the slope. So we're going to look at both situations. We're going to look at 1996 and 14.7, and 2006 14.14, and then we'll look at 0 14.7, and we'll look at 10 14.14. We'll look at both situations, and what we're going to find is so I'm going to use my y2 minus y1 over x2 minus x1. And what we're going to find is if we do the subtraction here, 14.14 minus 14.7, so we get negative 0.56 over 2006 minus 1996, which would be 10. And if we do the division here, we get negative 0.056, and that is our slope. Now, if we do the same thing using the second ordered pair, we're going to get the same thing. M is equal to negative 0.056. And this makes sense that we would get a negative slope, right? Because as the years have grown, as we've gone from 1996 to 2006, the birth rate has dropped, and so we should be getting a negative slope. So we have a negative slope of negative 0.056. So there's our slope. Now we want to write an equation. And so we can use y, let me just erase that here, sorry. Y minus y1 is equal to m times x minus x1. We can also just use y equals mx plus b. We'll do both, okay? So we know what our slope is, negative 0.056. So this is where naming your ordered pairs is kind of important. If we use the original, or the first set of ordered pairs, right? So here's what we used here, 2006 and 14.14. We're going to take this information and we're going to plug it into either one of these forms, and I'll show you both. So I'm going to use the first ordered pair just because it's the first. So we would substitute and put y minus 14.7 equals negative 0.056 x minus 1996. So y, and solving, y equal minus 14.7 is equal to negative 0.056x. I'm doing the distributive property. And then I got to do negative 0.056 times 1996. And when I do that, I get positive 111 point, I'm going to round up, 111.8. Adding 14.7 to both sides, to 14.7 to solve for y, and we get y is equal to negative 0.056 plus 126.5. If I want to use y equals mx plus b, we can do the same sort of thing. We substitute 0.056 for the slope, and now we need to solve for b. So I'm going to substitute value for y and a value for x using one of our ordered pairs. So I'm going to use 1996 and 14.7 again. So I'll put 14.7 for y, and I put negative 0.056 times 1996 plus b. 14.7 is equal to negative 111.8 plus b. Add 111.8 to both sides, and we get b is equal to 126.5, which is that right there, right? So this is one of our possible linear equations to model this information. Y equals negative 0.056x plus 126.5. Okay, so that's one of the possible equations. But what if we used these ordered pairs? And 10, 14.14. Well, what's good, right, about that is that this is the y-intercept. And we know this because x is equal to 0. So our equation could also be written y equals negative 0.056x plus 14.7, which looks really different than the other equation that we found. Oops. The other equation that we found, which looked like this, 126.5. So this is why defining your variables is going to be really important. Here, x is the year. Here, x is the year since 1996. So what we substitute in for x into our equation is going to be significantly different. And that's going to be really, really important here. Okay, so here is a second version of the linear equation, but you got to make sure that you've defined it so that X is the years since 1996. Okay, so let's see if we can put this to use. All right, so what if I want to estimate the birth rate in 2016? Negative 0.056 x plus 126.5, y is equal to negative 0.056 x plus 14.7. And we'll see that we're going to get the same answer. All right. In this situation, though, x is going to be equal to 2016. And in this situation, x is going to be years since 1996. And 2016 is 20 years since 1996. So in each situation, I'm going to substitute in for x and solve for y. So negative 0.0556 times 2016 equals y equals negative 112.9 plus 126.5. And if we do our subtraction, we get 13.6. So in the year 2016, the birth rate will be down to 13.6. Now, what if we use this equation and we plug in 20 for x? Let's see what we get. Y is equal to negative 0.056 times 20 plus 14.7. And negative 0.056 times 20 gives us negative 1.12. And if we add that to 14.7, we get 13.58, which I'm going to round up to 13.6. So in either situation, using either of these equations, you get the same answer. You just got to be careful about what you're substituting in for x. Okay. Last but not least, what if I want to use the equation to figure out a year? So in other words, we're solving for x. So again, using the two different equations, I want you to see that we'll get the same answer. So in this situation, we know that y is equal to 13 because it says births per 1,000, right? So that means we're talking about y. So I'm going to plug in 13 for y. And let's see what happens. So I'm going to subtract 126.5 from both sides. And we get, let's see here. Let me use my calculator here. 13 minus 126.5. And we get negative 113.5 is equal to negative 0.056x. Divide both sides by this. So divide by negative 0.056, and we get, oh, sorry, let me try that again. Negative 113.5 divided by negative 0.056, we get, hold on. If I do my division, I get x is equal to 2026 or thereabouts. Let's try it over here. 13 is equal to negative 0.56x plus 14.7. I subtract 14.7 from both sides. I get negative 1.7 is equal to negative 0.056x. We do our division, and we get x is equal to 30. And that seems really weird because the other answer we got 2026. But if we remember that in this equation, this is years since 1996, well, that would be the year 2026. So in the year 2026, the birth rate in the United States will be down to 13 births per thousand. So that is a short video of how we can generate a linear equation based on information from a word problem.